Alright everybody, sit down. My name is Mr. Smith. Today we will be learning AP Physics. Do you have any questions?
Oh, teacher, I have a question.
Yes.
So, yesterday I was playing in the rain. You know, I like playing in the rain because like I get my boots wet and everything. But basically what I did was I saw a puddle on the ground. It was a pretty big puddle, and it was standing water. You know, it was really calm water.
Calm water, eh?
Yeah, calm water. You know what I'm saying? And I had two rocks in my hands. You know, two rocks. You know, teacher.
Yes.
So they were the same size, same mass, and everything. But I dropped them in the puddle at the same time, and they both created ripples. You know what ripples are, right?
Yes.
They're like the concentric circles that go out from
yes.
the rocks.
Yes, people.
Because of Okay. So the ripples, when they hit each other, they did some weird thing where like some of the ripples went away, some of them got bigger. So like, can you explain this phenomena to me? And can you like, I'm just really confused like on why this happened.
Excellent question. But before I can get to that, I have to explain to you the phenomena of constructive and destructive interference. Then we can get on to your question about the rock and the puddle and the waves that they created. Yes!
So like, what is constructive and destructive interference?
Excellent question.
Interference occurs when two waves meet while traveling through the same medium. At the point of interference, or where the two waves are overlapping, there is said to be constructive interference or destructive interference. Constructive interference occurs when two interfering waves overlap and have amplitudes that have the same direction of displacement, and thus their interference creates a larger wave in that direction. Destructive interference occurs when two interfering waves overlap and have amplitudes that are the opposite direction of displacement, and thus their interference creates a smaller wave in that direction.
Wait, what? I
Yep.
don't get it.
Honestly, I don't get it either.
Think about it as a wave going this way and a wave going that way. Now you see, this first wave has a positive amplitude and is heading this way. This wave also has a positive amplitude and is heading in the direction that this wave is coming in. When these two collide, there will be interference. And the type of interference is based on these relative heights. So if you look at the result of this, you see that the interference caused by these two has created a greater amplitude in one wave. This is known as constructive interference because these two amplitudes have combined to form a wave with a greater amplitude. The next thing we're going to learn about is destructive interference. It's similar to constructive interference as in both the waves collide, but in this case, one wave with a positive amplitude is going in this direction, and another wave with a negative amplitude is going in the opposite direction as this one. When these two come together, there will be interference. Again, this type of interference is known as destructive interference. This will lead to a wave that's relatively short in positive because, as you can see, a relatively short wave with a positive amplitude. That is because this wave right here has a greater amplitude in the positive direction, and this wave has a lower magnitude in the negative direction. So think about it as a value of numbers. Say this number is 5 and this number is 4. Because this number is negative, this basically think about it as 5 minus 4 gives a wave with an amplitude of 1. That is known as destructive interference. When two waves come together, one with a positive amplitude and one with a negative amplitude, to create a wave that has the difference in absolute value of these two amplitudes. What do you think?
So teacher, could you look at this?
Absolutely.
Okay, so here I have the homework problem that you gave us. So we have one wave here shown in red and another wave here shown in blue. And I guess I'll do my homework in green. So at this first point, there's no interference, is that correct?
Yes.
So technically it starts at 0, right?
Mm-hmm.
Now, what about at this point, at like about 1.5? So both of these waves have, they have peaks and the blue one has a peak at 1, and the red one has a peak at 2. So,
correct.
What would that translate into when these two are, interfering together?
Well, like I said, is you see these amplitudes are both positive.
So, if you think about it, this is a form of constructive interference. So, in this case, you would add up the amplitudes to get the resultant wave.
Which is 3.
Yes.
So, the resultant wave is 3 units high at 0.1.5.
Yes.
So, would you say that the wave is about like this in how it looks?
Yes, that is true. That's correct.
And so if you continue that all the way through, say like until here, the wave would continue to look like this. Is that true?
That is right.
Okay.
And this is known as constructive interference.
Okay, so maybe... So this first part is correct. Okay,
Yes.
so now heading to the second part. This part is a little bit challenging. So we have one wave that's going underneath the x-axis, so to say, and another wave that's going above it. And both of their amplitudes at 0.4 are, at like 4 units, are -2, right?
Mm-hmm.
So how would I figure out where the superimposed wave is?
Well, you see, in this case, you see that this wave right here is negative, and this wave up here is positive. So in this case, what type of interference would that be?
So that would be destructive because the two waves are going in opposite directions. One is going positive, the other is going negative.
That is right.
Okay, so as you had told us, when it's destructive interference, one is positive, one is negative. That is what destructive interference is. And at that point, you add those two together and you get the resultant wave. So in this case, this one is +2 at 0.4, and this one is -2, like right here, at 4 units. So would you say that the resultant wave is 0 at this point?
Yes, it is.
Okay, and heading up to that, they're both going at the same rate, and they're both heading to +4.
Mm-hmm.
So would you say that it's a straight line all across?
Yes, it is.
And okay, so it's like up until about here.
When you think of destructive interference, think of it as these two waves are kind of canceling each other out. You see, this is going positive and this is going negative, so essentially, if they're the same, basically identical waves, but in different positions, they're basically going to cancel each other out, and they will be a straight line. And this straight line is known as the superposition.
Okay, so the superposition. Could you explain that in depth a little bit?
So, like, if this is 3 and this is -1, is the answer 2?
Yes, it is.
Alright. Like that?
Yep. Can you tell me what type of interference this is?
Destructive?
That is correct.
Alright.
Good job.
Wait, so I'm like stuck. What about negative and negative?
Well, what type of interference do you think this is?
Constructive?
That is true. Can you tell me why?
'Cause they're both like negative?
That is true. Remember what I said about if both of them are the same sign, as in positive or negative, you would just add them together. So can you tell me how the wave would look, the final wave?
So it's like extra negative?
Yes, it is.
Well, students, you can see these 3 examples are all examples of superposition. Superposition is basically when waves interfere to create a new wave. When waves interfere with each other, when the waves come together and they form a new wave, that wave is known as a superposition.
All right, thank you, teacher. So, just to give an example to the class, my dad was telling me about this new earphone that's come out, a couple of years ago, that Sony and Toshiba and all these big companies, like earphone companies, have come out with, and they're really cool. They cancel out noise. So I was wondering, I always thought that they had some special material that blocks out noise, but actually what they have is they have a microphone inside of the headphone that transmits waves that are 100 degrees, and they're equal to the waves of like outside noise. But what they have is they have the same amplitude, but they use destructive interference to cancel out the other noise. So the only noise you hear is the noise from your, like the MP3 device or whatever you have. So, I thought that was pretty cool. So, I thought I would just tell the class and share my story.
Excellent job. That is a great example of what we've learned today.
Thank you, teacher.
Class dismissed. Good day.